Okay, ready? Of course you are. Born ready. Here we go. All right, so let me make my two-way tables, the one I made yesterday with the males and females and those that drive to school and those that don't drive. And I'm going to use the same numbers as yesterday, 20, 40, 30, 10, 60, 40, 50, 50, 100. Okay, so those were the numbers that I gave you yesterday. And off of this, let's see if we can figure out the probability that I pick a student at random and they're male. What was that? 60 out of 100. Probability that I choose a female who drives. Yes, that's why I'm going to write it out of the whole set if I just do a plain old and. Point 3. Now I need to figure out the probability I pick a female given that I've got somebody that drives to school. So the probability of female given somebody that drives is the probability that they're female and drive over the probability they drive. Point 3 over my drivers are 0.5. Okay, so there's how my conditional probabilities work with a table. Okay, so notice the probability that somebody who's a female and drives, given that they're a driver, is 30 out of the driver's row is 30 females out of the 50 drivers, which is 0.6. You can figure it either way. Okay, so let's try to get as far into this another example as I can for the bell rings. How much time do we have? About a minute? Okay. So very quickly, I'm going to say 20% of students at Aragon are athletes. Whatever. 14%, no, made these numbers up. 14% are female athletes. 14% of all students are female athletes. And 56% of all students are females. All right, I want to do some probability problems with this, so I'm going to set up a two-way table. You're either female or you're not. You're either an athlete or you're not. Okay? So let me put this data into this table so I can answer some question about it. 20% of students are athletes. 20. That means 80% aren't. Okay? 56% of students are females, which means 44 are not. And 14% are female athletes. Oh, that goes right here. Can you fill in the rest of my two-way table? What goes here? What goes here? 56 minus 14? 42, thank you. I can add. And what goes here? 44 minus 0.06, 38. All right. Now I can answer any probability questions with this. What's the probability you are a male athlete? 6%. Etc.